Welcome to this talk called Sociotechnical Design for Software and Human Systems. So what I'm going to share today is my developmental journey. So you're going to hear the leading edge of my thinking based on my personal experiences, which inevitably will be colored by my biases and my lenses and my filters. But, so it's true for all the other talks as well. But nevertheless, I would like to ask you to engage critically with this particular talk. So let's get started. So first, a few words about me. I am Xin. I'm an independent consultant based in Copenhagen, Denmark. I have DDD and architecture as the main thing in my toolbox. So the more visible part of my work life can be captured by this feedback loop on the left-hand side. Okay, so I can't really use my spotlight, obviously, but okay, so that one actually says the more consultancy I do, the more DDD outputs I'm going to produce, like workshops, domain models, and architecture documentation, and that's going to bring me more business. So that's a pretty neat reinforcing loop like that. But, personally, what I tap most creative energy and drive from is actually the loop on the right-hand side. And that one actually says, the more consultancy work I do, the more I would be contributing to sociotechnical design and systems leadership. Basically that means leading bottom up and leading sideways. So in a way, you can say most people see my public facade as hopefully a capable consultant and someone appearing in podcasts and speaking at conferences like this, but most people don't see my ninja outfit and my invisibility cloak as a undercover change agent, but some do. All right. So the structure of today's talk is really quite simple, quite binary. We'll start by looking at the sociotechnical complexity in software system design before we proceed to the design of our work, our social systems. But since complexity by definition is nonlinear, there will be some overlaps, intertwinings, and back and forth between these two parts. Okay, so when I graduated as a computer science major 15, 16 years ago, I imagined a neat and tidy software career for myself. I was really keen on tapping into the computing power and the precision of software to solve really, really tough problems in the world. And back then, every hard problem in reality for me could be formulated as an optimization problem, like the traveling salesman. And they should be able to be solved using a scientific approach with variables and algorithms. So I was deeply fascinated by the big O notation, that software is logical and it compiles, especially if you have a language with a compiler. And even NP hard problems would have some sort of deterministic solution, if not a completely right or wrong answer, at least a mathematically provable range of optimal solutions. So, in many ways, you could say that I really subscribed to this idealistic Newtonian worldview that the universe is a giant clock. The laws of nature act like gears and springs, causing everything to move in a predictable and orderly way. I like that. I liked that. Still do in some way. Then I joined a consulting company as a software developer and got assigned to my first software project. So real-life software project. And that was a fixed price delivery. So at the beginning of the project, we got these two big documents. So really huge Word documents with very thorough requirement documentations or requirement specifications produced by the client's business analysts. And then almost an equally thick SAD document, so that's a software architecture document, produced by our own architect as an architecture blueprint. As you know, back then, big design upfront was in vogue. And so the project was delivered as a waterfall project using something called RUP, Rational Unified Process. Some of you might know it. And we were a great team of 4 developers, and we delivered on time within 6 months. So that the domain is the insurance workflow. We're supposed to develop a standalone system for that. So We applied a lot of design patterns from the Gen 4 book, and that was in the middle of 2000, and we also had a rock solid implementation of the solid principles, which is actually pretty new, and so we were sort of one of the first movers. Very proud of that. But our software never made it to the users. This was pretty much the reaction we had when we received the email message from our project lead informing us, our software was not going to production anyway. And for the client, the 6 months hard work of our life was as good as never having happened. So, what was the rub? So first off, the client's business analysts misunderstood, or rather oversimplified, some user needs, and we in turn misinterpreted some of those email replies from the business analysts from the client. That was the primary communication form between us and them. And then the client, the determining factors were that our business sponsor, that is the person who hired us as a consulting firm, didn't really align with the parent company, that is his boss, to start this project. And because of all that secrecy, no one told us that a mandatory front-end framework needed to be used. And when those architects from the ivory tower, from the parent company, looked at our code, they said, it would be too costly to rewrite all of this. So our project was dropped, shelved, and forgotten. But we got paid really well. We delivered, right? So we got praised for applying design patterns and solid, and we had a lot of technical learning and experiences. But obviously, we were not happy. So that was kind of my first existential conundrum in my software career. It turned out that the world of software design is not a giant clock after all. Design cannot happen in a closed system, and there is a long way from being neat and tidy to being useful. Software's value is always evaluated in context, right? And software systems are also these open systems, constantly exchanging input and output with its environment. Also, software's context is full of decisions that can go wrong, right? So the leadership team on the left side, they could pick the wrong direction, and the product people could, end up deciding we should build something that really doesn't matter. And the development team, that's us, could build the wrong things and build the things the wrong way. Architecturally, if that decision was wrong, and then poor operational decisions could lead to incidents and outages. And not only can decisions go wrong in each of those individual bubbles, decisions are also interdependent, making the whole story even more difficult to piece together. So that was kind of like a turning point in my career. I decided I would be a software architect, if not for anything else, just to increase the odds that I would understand the whole story, and never again in my life I would like to use 6 months of my life on doing something not useful. So, as a newly baked architect, I found out soon enough those box and lines architecture diagrams were not so easy to draw, because software's context is so full of human relations. So from the left-hand side, from the software's maker to the user, there's a route. And on that route, there was information handoff, there was relaying of decisions, there were a lot of human load balancers, right? And I guess what I was brought face to face with was something called sociotechnical complexity. And now these days, when people see the term sociotechnical, Chris said it was buzzword compliant yesterday. So people tend to think, the technical is the software, and the social is the teams. So if we do a kind of, inverse Conway, doing the socio-technical mirroring of team APIs with the software boundaries, then we're done with socio-technical design. In my mind, that is a pretty reductionistic and superficial way of understanding socio-technical. Here's my take, based on my research and my personal experiences. So, technical complexity, can't use this. So, technical complexity, the bottom part, is the complexity that resides in the discrete parts of a system. So a discrete part could be a piece of code, could be a module, a subsystem, but it could also be a task, a Jira ticket, or it could even be a team seen in isolation. If technical complexity were the only complexity in a system, then we could potentially solve everything with divide and conquer, right? Because per definition, there is no complexity between the parts, and if we solve the problems within each parts, then we would sum up to a total solution for the system. However, the social part, the social complexity refers to the complexity in the relationships between these discrete parts. And so that's a relational complexity, the social one, and that typically manifests in interfaces, meetings, decisions, and practices, right? Human to human. So just to exemplify, so assuming that 6-part model on the right from the Sociotechnical Center from the University of Leeds is correct, the technical complexity would be, that within each node, right? So how do you work with the goals and metrics, processes, and culture and technology and infrastructure and people? And the social complexity would be in those lines connecting those nodes, right? And then some of you might say, some of those lines are connecting pretty technical parts like technology and infrastructure. What's so social about that? But if we really think about it, that is also a relationship, a communication between the people working with these things, that there is also the derived relation, right, between the user's perception of what needs to be done in these areas and the engineer's perception. So it turns out that what many people fail to realize, as Peter Block points out, is that relationship is the delivery system of everything we want to accomplish. Also the technical goals. So if you look at domain-driven design as a practice, I think this practice is really about visually modeling the whole part and part-whole relations. So this 3-part model was originally hand-drawn by Paul Reiner, the organizer of this conference. So basically, this model says that there are 3 core practices in DDD. So coming from the top left, so the strategic design is really about taking a modeling approach to answering the question of the what and the why, right? What software are we building? Why are we building it? The tactical design is really how to build and connect software for longer-term changeability and understandability with expressive models, right? And then we have the visual collaborative modeling on the bottom. That is really about modeling relations. That's the question of the who. Who do we work and create value together? And who else do we need to align understanding with in order to have success? All right, so people tend to say that silver bullets don't exist. But there is this one practice in our DDD community that's almost approached the silver bullet status, and that would be event storming. Have you ever wondered why event storming works magic almost every time, with few exceptions maybe? So for me, event storming started with the granular view, so the individual perspectives. We diverge before we converge. So we see the trees and then the forest and then the forest again, step back, but not at the same time, right? We don't have these human load balancers. We don't have information handoffs. We have this massively engaging and inclusive conversation experience in event storming. So I think the magic of event storming can be explained by some complexity theory, namely that knowledge is created, not shared. So I'm going to argue against knowledge sharing here because, as Dave Snowden says, complex systems scale by decomposition to the lowest consistent level of granularity and then recombination. They do not scale by imitation or aggregation. So in order to really make complexity manageable at all in our complex systems, we need to have these 3 principles, according to Dave. That would be granular discovery, distributed cognition, and disintermediation of data. And if we look at it, this is exactly what we do in event storming and similar practices. So next up, I think it's virtually impossible to explain strategy to engineers by handing them a neat and tidy PowerPoint document or a one-pager, or even inviting them to a town hall where some director, makes a presentation about strategy. But we can make engineers understand strategy by engaging them in a collaborative discovery process where they can trace this value creation hypothesis linking strategy to everyday work. And now this workshop format was originating from the product management community. It's called the North Star framework. Basically, it's a workshop practice that attempts to build a compelling big picture that connects two types of models. The model of strategy on the left-hand side, the value-related bets with a longer time horizon, and then the model on the right-hand side with strategy deployment, that's the work-related bets. So what we're trying to achieve in workshop formats like this is to build a shared and deeper understanding of the why in order to help everybody to find their place in the story. So when a developer wakes up in the morning and goes to work, he or she can clearly answer the question, how does my contribution matter in the big picture over time? So, like Deming said, joy in work comes from understanding why our work is important, not from the work itself, but from the knowledge of who's going to use it. And I think through my work with DDD and related practice that I have shared, and many more that I don't have time to share today, that sort of also shaped my perception about why and how my work is important. And so the joy in my work has now become to architect for value coherence, to lead with the why, not the way. And this is a documentation of a DDD workshop series I have facilitated during COVID. And that's starting with the why, the architecture one way, the worldly mapping, event storming, and just freestyling whiteboard sessions with business discovery before we proceeded to the way with strategic DDD, tactical DDD, architectural patterns, and then even some event modeling, and then we documented everything with the bounded context canvas. We have the inventor of that one sitting in this room as well. So, so far we explored social-technical design with software as the centerpiece, right? Event storming, everything, that's with the software in the middle. But software's context is also a system of systems. So I am a system, my team is a system, interacting with other teams, and then we are all embedded in this big organizational system, which is under the impact of the environment, which is another ecosystem. So then our organization obviously also influences the ecosystem through the products and services we put out, right? So that brings us to the second portion of today's program, or this talk. That would be the design of our work and our social systems. So in our postmodern era, as our software industry matures, every business now is a software business. So every elegant piece of software will eventually become a legacy system. Time only flows in one direction. So we now have aging companies with aging software with compounding social-technical complexity. So a lot of people are frustrated by this. So, is complexity a bad thing, right? So the talk in the Gold Room is about simplification of complexity. So should we simplify complexity? Not entirely so if we factor in Ashby's law of requisite variety. And Ashby's law basically says in order to deal properly with the diversity of problems the world throws at us, we need to have a repertoire of responses that are at least as nuanced as the problems we're facing. And so for every organization, the environment has variables we would like to keep in control, right? In order to have that, we need to have control points for each of those variables we would like to keep in control. So like Jay Bloom says, we can choose how much environmental complexity we would like to consume based on how much of that environment we want to occupy. And roughly what that means is that the larger a company's market, the more customer types we want to serve, and the larger the geographical radius we want to cover, the more complexity our organization would need to have in order to deploy the strategy. So that's sort of strategy. So as per, this is also called requisite complexity. So complexity is not only not bad, it is good and necessary. It just needs to be designed for. So it follows then we need design thinking for our software systems. We also need design thinking for our social systems. In my mind, we've come a long way with DDD and friends when it comes to software design. So by friends, I mean the adjacent possible practices that share the same underlying principles and philosophy with DDD, namely taking a language-oriented and modeling approach to tackling complexity. So here you see product thinking, software architecture, strategy, DevOps, collaborative modeling in general, and systems thinking. So what about the design of our work? Here, I personally see a really big divide between, on one hand, on the left-hand side, a really, you can say, mechanistic and divide and conquer based, but nevertheless pretty optimistic approach to tackling social complexity in organizations. So roughly that would translate to, this sociotechnical mirroring in a lot of organizations, rework transformation with the scaled agile framework and so forth. And then the divide is between the optimistic and mechanistic approach on the left-hand side, and then on the right-hand side, I think I also observe a rising level of pessimism and skepticism about this, especially when the fixes the left side try to deploy don't really work. Agile will never deliver value. Reorg and transformation projects are doomed to fail, that sort of things. So also called learned helplessness, because you have seen it so many times. So for those of you who know Ken Evans, so the left-hand side is a little bit like seeing the organizational system as in the complicated domain. So the solution approach here would be analytical, scientific, expertise-based, and then on the right-hand side, it was like seeing this big organizational systems as a kind of a chaotic domain, meaning it's uncontrollable, inscrutable, unable to be influenced. So the right-hand side, it's like seeing the human systems like they're too complex to manage. Maybe the best thing we can do is to see who has the best jokes about Safe or or Spotify, right? Right. So we've come a long way with DDD and friends with software design. I think we're massively struggling with the design of our work. So, but the paradox is that, like for any other things in life, the goal is in the struggle. So if we look at biology, obstacles and challenges are an essential part of the evolution of all life forms. For me, there is something hopeful in this word, in this phrase, complex systems. Yes, it is complex, it is intractable, but it's also a system. Being a system, it has an identity, it has a boundary, it's easy to see what's in and what's out. It's just like when I say, my child has grown so much. Yes, I'm referring to, there is constant change in my boy, but it's the same person that has grown, right? So there's a kind of sameness, slowness, and stability despite of change. So I guess what makes me hopeful is that what is complex is also systemic. If we double-click on the word complex, we see properties like interdependencies, entanglement, emergencies, things are in flux and changing, and cause and effect are at best far apart in time and space, and at worst, not even knowable. But if we then double-click on the word systemic, we then see a stable identity, boundaries, order, slowness. We have an intuition that a system, your company, has these norms and rules and social contracts and structures and culture. It's goal-seeking. It has these preferential relations, making a social system's disposition discoverable, workable, and architectable. How can I make use of this this hopefulness to help me navigate a complex world? Is there a theory or framework I could follow? So I don't know about you. I have these daily doses of my professional social media content. So LinkedIn, Medium, and Substack. I feel new ideas and frameworks are being thrown at me with dizzying speed these days. I can't fit everything into my head. So then I came I need a surviving strategy, I feel. So then I came to think about this observation of Russell Ackoff, that when we human beings make sense of the world, all our explanations rest on certain assumptions we make, right? And behind every assumption, there is a theory. So something we believe in. Every theory rests on a more general theory. The most general theory would be the theory of reality and a concept about the nature of the world. So it would be pretty presumptuous of me to try to find the most general model of theory. But if I can find a more general theory, maybe that would help me better relate to all the other theories and frameworks. So in my quest, up until now, the most inclusive and interpretive sense-making framework I found extremely useful is Alicia Guerrero's constraints framework. I think it beautifully unifies system thinking and complexity theory, and it resonates with my ontological belief that reality is complex but systemic, which makes it relatable, communicable, and influenceable. So a central piece in Alicia's constraints framework is the notion of enabling constraint. So the idea is by limiting variability, enabling constraints increase the freedom in the whole system to take the next action or make the next decision. So a good example would be syntax and grammar in our language, right? By limiting the linguistic combinations, they allow meaning to emerge and they help us communicate. Imagine a language totally unconstrained by syntax and grammar where every combination is possible, then it would be completely impossible for us to communicate. So I think I only have time to give Alicia's very profound theory a pretty superficial treatment. So oversimplified, it's a 3-step process. So in step 1, we have enabling constraints working bottom up, generative. So generative means to create, to generate, like in generative AI, and opening up options, but not through cause and effect. What they do is that they induce the conditional probability of initially separate events, processes, and entities to become interdependent upon each other. So then these newly enabled interdependencies then coalesce, being unified, right, as a coherent dynamics entering the higher level context and the interdependent whole. So to be concrete, an example of enabling constraint in my mind is usually these catalytic enabling constraints like participatory discovery, visualizing, languaging, modeling, reflective conversations, and then feedback loops. So the way, as knowledge workers, the production factor for us is actually information. So information flow matters. So catalytic enabling constraints, what they do, how they work is that by catalyzing or impacting the speed and direction of information flow, they change the conditional probability of our future decisions and actions being interdependent with this catalyzed information. And feedback loops works in almost exactly the same way. If you think about feedback loops, it's really information being ingested into the context, and then making that information, it's making it conditionally possible for future decisions and actions to become interdependent on that, newly available information from the context, from the feedback loops. Yeah. So step 2, that's relatively intuitive, that we have the environmental feedback, stabilizes this newly coalesced coherence. So then what happens here is that the box which says the whole, that's the organization, it puts products and services into the environment, and then value creation hypothesis is tested in the environment, right? And then design is evaluated in use. And then we have this constraint closure with the environmental feedback loop, which stabilizes this coherent dynamics and expands the system's phase space. So phase space is basically all these points a system is able to reach by making the system more relational, more interdependent, and more complex, as per Ashby's law, as per our requisite complexity, the system has more optionality. So examples would be, when startups become scale-ups and continue with the processes and rules even that have been coalesced and stabilized. Or in the opposite case, we have these disrupted industry where the environmental feedback is like nudging these organizations to say, you need to really adapt your internal dynamics to survive, right? So in step 3, we have constitutive and governing constraints to persist and strengthen coherence. So how that works is that, we have these bottom-up enabled coherences, right? They manifest as almost like software interfaces, right? They manifest as these interactional relational types and patterns, and these patterns then become multiply realizable or multiply realized in a system-wide architecture that persists and strengthen these interdependencies within coherent dynamics, right? So then I had a long conversation with Alicia on this piece. So the temporal coupling here is that we have a second order constitutive constraints regime that arises concomitantly and organically with the bottom-up enabled dynamics, right? And these constitutive constraints then embed themselves into the higher level context, acting top-down as governing constraints. So then maintaining order, restricting behavior, and strengthen the system's identity. So examples are everywhere. Every organization's contextual framework are like these constitutive and governing constraints. The norms, rules, social contracts, practices, and culture, they constrain and organize events and processes within coherent boundaries. So hopefully you can see that how a system's identity is formed through coherent dynamics, first coalescing, then stabilizing, then persisting and strengthening through the working of constraints. So according to Alicia, constraints are what organize a complex mess into a coherent whole. Constraints are what constitute a system, that is, what makes a system through these preferential relations and experiential coherence, right? So once these 3 steps are sort of completed, the resulting coherent dynamics can be extremely resilient, surviving the most disruptive forces from the environment. You can see in the case of a new CEO entering into the company, he can be, or she can be quickly assimilated into the existing company culture. Or just think about in the case of Twitter. When Elon Musk tried to disrupt a very mature and very resilient company culture by bringing in forceful disruptions from the environment and the oscillations it caused, and then the massive exodus of Twitter engineers. So in many ways, Twitter, or X, is still going through this phase shift with dramatic conflicting forces at play. So next off, I'm just going to use the last minutes to give you a few examples of how I use these constraints, the constraints framework and theory, to help me with social-technical design in my work. So this piece is about visualizing work as a catalytic enabling constraints to help people see the whole system. So now this particular model is the 7 elements of visual management from Jim Benson. I'm not saying this is the model. This is just one model out of many that I find really inclusive and coherent in pointing out the essential elements of our work. So on the top level, you have the tactical information of state and triggers. That's another way of saying planned and unplanned work. How do we relate to those 2 pieces? And then the strategic information, the direction where we're going, and the narrative again, the North Star again, the model linking strategy to everyday work. That narrative through our discovery, decisions, and design is extremely important in software design, in my view. And then we have the bottom level, we have the cultural information. So those three pieces, culture is really what makes a team, and the professionalism is really about how do we learn together, how are we professional together, right? And finally, last but not least, how is work meaningful for me as an individual? How can I find autonomy and agency, right? So that is a derived piece from that, an example. This is actually from my current client, actually with inspiration also from Joe Yuda. This one is actually a team daily stand-up prompt. In the systems architecture team in Milestone Systems, which is a architecture modernization team I'm currently leading. And this is like in the 15 minutes, this is what we do. It's not like we're going through these 8 questions slavishly, right? But each architect is pulling the stuff that matters to them. And then we talk about how are we doing, how are we being, how are we feeling as a team, right? So this is, again, the doing is about the planned work and unplanned triggers, and the being is really about how do we care for each other, how do we help each other, what's the workflow, and what's our whip level, and how's our psychological flow, right? And the big picture is it's one of the pieces that people pick most because it's really important for people to feel that things hang together as a big picture, and it's coherent because we're talking about an architect team. So, and how are we feeling about agency and affordance? So really, this is about to have a non-invasive and pervasive way of visualizing the essential elements in our work and have a discussion about it so that we can work in a calm and professional and non-stressful way. Yes, okay. 2 examples to go. This one is about emerging constraint closure as a virtuous probability cycle through in this particular case, we have the workshop format called development value stream mapping. What I discover is that when a team that is not used to talking about work in a visual and talking about improvements in their work, when they do engage in such conversations, a lot of feelings actually surface. So I observe a lot of languaging, emotioning, and basically deep reflective conversations as enabling constraints that coalesce and stabilize these social contracts. You might not be able to read it. It says PDSA and pool planning and accept the good interrupts. This particular team has identified these things to work with. So PDSA is a lean practice, it's plan, do, study, and act. So then once these social contracts have been, emerged, they then act top-down as governing constraints, right, voluntarily. So we have this virtuous probability cycle. The reason it's a probability cycle is not a feedback loop. It's not cause and effect. It's because that line bottom up depicts a emergent and probabilistic relationship. The line top-down is then more causal and more repeatable. So, finally, we have an example here called boundary-driven sociotechnical architecture. So a lot of people, when they talk about boundary-driven architecture, people think about, APIs across systems and team APIs again. So in my mind, to deploy such governing constraints to begin with, is a danger because there is really nothing to be governed unless something is constituted. And what is constitutive is really this experienced coherence through these conversations, right? So a more productive way of doing this is through enabling constraints, like on the right-hand side, boundaries, social practices that catalyze value coherence, interface negotiation, SLOs, and visual modeling. Like these are constitutive constraints, right? And so constraints are context dependent. What works for me doesn't necessarily work for you, and vice versa, right? Like you can't copy and paste the Spotify model. So to conclude, I think in terms of work design, DDD and the adjacent practices You may not be able to read it, but it says sociotechnical architecture, reflective conversations, languaging, emotioning, visual modeling, sense-making, complexity theory, constraint modeling. Those practices hold great potential as enabling and constitutive constraints. Sociotechnical complexity can be designed for. We just have to remember the goal is in the struggle. We cannot directly go to top-down governing constraints, asking for obedience without really constituting a more visual and relational and healthy way of working. Right, so we need to design for stability and for variability. And my design goal has become this term called coherent heterogeneity, which is coined by Herbert Spencer. And then I further break it down to these two go-to principles that both start with A, affordance, and agency, which is a mirror-logical relation, whole part-whole relations. So affordance is really what is afforded from the context to allow the system to balance this stability with variability. And agency is really what goes beyond autonomy. So autonomy is like when an agile team is empowered, they are autonomous within their own agile bubbles, but when we have agency, we have the feeling that we're able to influence decisions and we can take actions that cohere with the overall system's well-being and purpose. Yeah. So, navigating complexity is a developmental journey for me personally, and right now what I'm doing is actually redefining those lines on my change agent feedback loops from causal lines to conditional probability lines. And I need to constantly remind myself that social system design targets a possibility space, not a fixed outcome. Somewhere in me, there is still that girl who believes that the world is a giant clock. And that's why I'm talking about this in a conference, reminding you and reminding myself. Okay, in complex systems, it's not like, okay, since she's a change agent, here's the system she wants to change. Being a change agent, the change we're seeking will inevitably also change us. So like John Shar says, the paths are not to be found but made, and the activity of making them changes both the maker and the destination. But since I am a part of the system, I also have influence on the system. So that's the good news. So at the end of the day, I am an influential part or influential wave in the ocean. So are all of us. We just have to realize it. Thank you.